All right. Hi guys, welcome to our first live math lesson. This is a third grade lesson, so if you are tuning in as a fourth or fifth grader, fourth graders, your lessons will be on Wednesdays rather, and fifth graders, your lessons will be on Thursdays. So I'll see fourth graders tomorrow and fifth graders on Thursday. Third graders, and those are my children in the background. Third graders, we are going to be tackling two lessons today, lesson 24 and 25. We are going to be talking about graphs today. So so hopefully yesterday you were able to head on over to the school and pick up your math books. And so, you should have both your instruction book and your practice book at this point. So what I'm going to do is I'm going to go over the general concepts a little bit first, and then we'll work through some of the pages in your instruction book together, and then we will go over what pages you can practice on in your practice books on your own. It will also, I will also be available between 10 o'clock and 11 o'clock on Google Hangout. If you want to work through your practice pages with me then, or if you have any questions following this lesson. If you are unable to be here live with us right now, you can tune in anytime to this math lesson. I'd also strongly encourage coming back to it if you had things that were unclear about it. And so if you have, so that would be a good recommendation for a place to start. And if you have questions, if you are unable to be watching live right now and you have questions about how to, if you have questions about how to do the lesson, you can also pop in at other office hour times as well. Okay, let's get started. So behind me, I'm going to move my camera forward a little bit. Behind me, there is a poster that I made up, and the top says, "Why graphs?" Scatty wants to say hi too, but Scatty, it's not really the time. It's not your time to shine, sorry. So graphs are a way of organizing your data in a more visually appealing and sometimes a more visually clear way. So, data is something that you collect that is basically just information. So, for example, the data that I have collected in this sample is flavors of ice cream and how many people think that that's their favorite flavor of ice cream. So I'm going to move it a little bit closer, or try to. So this is my data set. I have it organized. This is called a tally chart because I have it organized by strand, and then the tallies that go along with that, representing how many votes. I also have it labeled so that it's nice and clear, and this is something that we've been working on in your performance tasks, is making sure that your information is both organized and clear. So some ways that you can do that, some ways that you can organize it are by making sure that you're somehow grouping your information together. And another way that you can make it more clear is by including labels. And labels are going to be super duper important as we start getting into graphs, because it's going to be important to know which part corresponds to which part. So, so I have flavors of ice cream on one side. I have it broken down between chocolate, mint chips, strawberry, vanilla, and bubblegum. Who likes bubblegum ice cream? Not really sure. Bubblegum in ice cream. Bubblegum's good. Ice cream is good together. There are votes along the side. So chocolate ice cream got 8 votes. Mint chip ice cream got 5 votes. Excuse me. Strawberry ice cream got 3 votes. Vanilla got 2, which is astounding to me because vanilla is clearly the best flavor because you could put anything you want on vanilla. And bubblegum, of course, got 1 because nobody really likes bubblegum ice cream. This, of course, is just a made-up example. I did not actually go out, especially since we're supposed to be staying at home. I did not actually go out and survey people on their favorite flavors of ice cream. I just went with something that I thought would be interesting to you guys, and I made up the results. However, what I think would be fun, and maybe we will do as an activity after this, is to create your own survey question. Go out and sample people remotely, so by email or by chat, and collect your data, and then you can make your own graphs from it that way. So we're going to be talking about 2 different types of graphs today. The first one is called a pictograph. Picto meaning picture and graph meaning graph. So we have an example pictograph right here. So you can turn it into something that's easier to, you can turn your data into something that's easier to visualize. So whereas you might not get the same kind of sense of which person, which ice cream flavor was the most popular through your tally chart, it's pretty easy to see with the tally chart, but it's kind of nice to give it a little extra pop by displaying it in either a pictograph or a bar graph. And we're going to talk about ways to do that first. So, so you'll notice that I have on my pictograph, I have a similar layout in that I have my ice cream flavors all down the side, and then I have empty bars next to them. There's a space up at the top for a title, and then down here is something, there's a little note that says this is important. On a pictograph, you always need to have a key. So before you fill in your graph information, you need to establish what your units are going to be. So in this example, I'm using, each picture is going to represent 2 votes. You can do it 1-to-1, meaning that you have 1 picture for every 1 vote. But then you're drawing a whole bunch of pictures. I would be drawing 8 pictures, for example, for chocolate. And so this is kind of a shortened way of being able to show my same data. Now, the reason I chose 2 was because I have 8, which I don't really want to draw 8 pictures. But I also have 1, which isn't very much. And so I didn't want to go with something like counting by 5s, which would also be nice and easy, but it wouldn't be a very good representation of my data because I would have a lot of kind of strange shapes in there to try to show 8 if each picture represents 5. So I chose 2, and you may be asking, well, what about the odd numbers? What about, we have 1, 3, and 5, and if each picture represents 2, how am I going to be able to show 5? So that's a really good question, and one that we are going to be going over in just a minute. First thing with your pictograph is it's nice to give it a title. Your title should relate to what you are asking, what is the information being presented. And so I'm going to title my graph, I'm going to title my pictograph, Flavors of Ice Cream. That goes along with my data set over here. And it also tells about what it is that I'm showing. So chocolate, mint chip, strawberry, vanilla, bubblegum, we could probably guess that those are ice cream flavors, but I'm just going to lay it all out there in my title. Now, again, remember the super important part, the key shows the picture and what each picture is worth. So I'm going to go ahead and bring my camera in for a second, and you'll notice that I have a picture that looks like an ice cream that's going to represent 2 votes. it's nice when your pictures can kind of match the theme, but also, as we've talked about, it's really important with math pictures that they are simple and easy to draw. So that's why I didn't spend a whole lot of time making cute little ice cream pictures. I'm just doing something that gives you the idea of an ice cream picture. Now, as I zoomed in, you probably noticed that I had already kind of sketched in the options, but we're going to draw them in together. So, so chocolate, if I look over here to my tally chart, I see that chocolate got 8 votes. I can tell that because I have a group of 5 and then 3 as well. So remembering my key that each picture is going to count for 2 votes, I'm going to go ahead and count by 2s until I get to 8. So 2, 4, 6, 8. I will be drawing 4 ice creams for chocolate to represent the 8 votes because each picture, remember, is going to represent 2 votes. So if I draw my first ice cream, that would be 2 votes. So that would be 2. The next one is 2 more. So now I have 4. Another one would be another 2, which is 6. And the last one would make it 8. So I drew 1, 2, 3, 4 ice creams, but because each ice cream represents 2 votes, I am representing my 8 votes with the 4 ice creams here. Mint chip has 5 votes. So now it gets a little bit tricky because if each ice cream represents 2, then I need to figure out a way to do half an ice cream, which would represent 1. So I have 2, 4, and then if I were going to, so I have 4 ice creams, but I need 5. So I'm going to do a half of an ice cream because if each ice cream represents 2, if I cut it in half, half of 2 would be 1. Now, this works when I'm splitting something in half. No, but if but if I have something that is more than, hey, Roque, you don't need to woof right now. Thank you. If you have something that is more, so like we talked about, if I had each ice cream representing 5 and I needed half of that, it would be a little bit trickier to try to demonstrate that. So 2 is a nice one because it lets you count by 2s, but also you can cut it in half if you have an odd number. If you have something higher, I would recommend trying to get as close as possible to to the number that you have, and that is kind of a limitation of pictographs. So pictographs may not be the best way to represent your data, depending on what your data set says. Now in this one, because I made my key represent each ice cream represents 2, I can cut it in half easily and it will represent 1. So I'm going to draw that half an ice cream. And there it is. All right, strawberry has 3 votes. So another odd number. So I'm going to go ahead and say I have 2 represented by 1 ice cream cone. And then I'm going to cut the other one in half to make it 1 to make those 3 votes. Okay. Vanilla had 2 votes. So that means that I'm going to go ahead and draw in 1 ice cream because remember, each ice cream represents 2. And so if I only have 2, I'm going to draw the 1 ice cream cone. And then bubblegum, bleh, has 1 vote, so I'm just going to draw a half an ice cream on bubblegum.
What are you drawing? What are you drawing?
I'm drawing a pictograph. I would also love it if you guys would say what your favorite flavor of ice cream is in the comments when we're done with this video because I'm curious. All right, Mommy, next we're going to be talking.
What are you talking?
I'm giving a lesson right now, honey.
We're getting a lesson.
Okay, Next, we're going to be talking about bar graphs. So we've kind of come to the end of pictograph. The main pieces of information are that you are representing your data with pictures. Keep your pictures simple because you may have to draw a lot of them. I didn't have to draw too many of my ice cream cones, but I still am grateful that I had a nice simple picture. And your key is your most important part of your pictograph. That means both if you are making your own pictograph and if you are reading pictographs, do not ignore the key because it's definitely going to affect your answer. Okay, moving on to bar graphs now. So bar graphs are graphs that represent the information with different heights of bars. So we could think of this as if there was a graph, each bar would be made up of different squares representing one unit. So we've talked a little bit, I think, about, maybe we haven't talked about area yet, but we have talked about units. So if you can imagine this as being kind of a grid, then I would be having each mark up on my line represent one unit. Now, I actually have been consistent with what my key was for my pictograph, and I'm actually counting by twos. So before we even get into that, though, I want to talk a little bit about some fifth grade math. So you guys are going to get a preview of fifth grade and middle school math talking about coordinate planes. So a coordinate plane is a fancy math term that means that you are looking at things on a grid. And so in coordinate planes, you have a y-axis, which goes up and down, and you have an x-axis, which goes side to side. So you can think of it as creating like a cross or an L. Your y goes up and down, your x goes side to side. In this case, where I am marking off my y-axis with different numbers, and that's going to represent the height of what my bar ends up getting to be for each category. Along my x-axis, instead of having numbers, because I'm not representing numbers, I'm using the flavors of my ice cream. Now, probably the most important thing, just like the key is the most important thing in a pictograph, probably the most important thing in a bar graph are your labels. You have one for your y-axis and you have one for your x-axis. My y-axis, each of these numbers represents a certain number of votes. So that's what my label is, number of votes. This symbol that many of you know as a hashtag, it's actually a number symbol. Also on old school phones, it's called a pound symbol. It's a very multi-purpose symbol, but a lot of times we use it to represent the word number. So I've shortened it to hashtag of votes, which really is meaning number of votes. So I have number of votes going up and down, and then side to side, I have flavors. So that's my second label, is I have my flavors down here. And I've kept it consistent by making sure that even though I've kind of had to shorten some of them, I've kept the same color coding so that we can see with our tally sheet that that's consistent. So now that you have your x-axis and your y-axis laid out on your bar graph, the next step is going to be determining, just like in your pictograph, how we determined our units of measurement by having the key. I'm going to have to decide what makes sense for my bar graph. Now, sometimes it may be, just like with a pictograph, it may be counting 1 to 1. So it may mean that you're not going to skip count. You're just going to go 1, 2, 3, 4, 5, 6, 7, 8, 9. I could easily have done that with my sample set, but I decided to keep it consistent with the pictograph and count by twos. Now, again, if I had counted by fives, I could do that too, 5, 10, 15, 20. But then I'm going way beyond my, my set. So if I look at the range of votes on my tally chart, I have between 1 and 8. 8 is my top number of votes. 1 is my least number of votes. And so really it doesn't make sense to do something that skip counts. Like, let's say we decided to skip count by 10. Well, that would be a pretty silly choice because my top vote isn't even the first unit. So if I just had one number on here that was 10, then I would have to make all these little smaller increments in between. It would be harder to read. So know that if you do label it with smaller increments, so for example, 1 would be the smallest increment, counting by ones, 1, 2, 3, 4, 5, 6, 7, and so on. You're going to have the most accurate bar graph. However, if you are doing a sample set, if you're collecting data that's in the hundreds, counting by ones is going to take you a long time. So really, when we're setting up our y-axis, the reason that we skip count is because we're trying to make it easier on ourselves. We're trying to make it easier so that we don't have to spend so much time figuring out our units. If my top vote was in the hundreds and I was counting by ones, I would need a really long graph to represent that. And depending on what my other information was, it may not be the best choice. If I counted by tens or 50s or even hundreds, I might have a better, well, probably not hundreds if it's in the hundreds, but I could count by 50s maybe, depending on what the number is, to still be able to accurately represent it, but not have it be so time consuming. Okay, so getting back to this bar graph, I have already put it in increments of 2. So I'm counting by 2s on my y-axis, 2, 4, 6, 8, 10. Now, I did go up to 10, even though my top vote was 8, because I didn't want the top of my graph to be the top limit. I wanted to give it a little bit of space at the top. There's also a space for a title up here, and I'm going to title it just the same thing that I did for my pictograph, just to keep it consistent, and also because that tells you what it is that's being demonstrated. So I'm going to say flavors of ice cream. Okay, so I've got my y-axis labeled with numbers. I've got my x-axis labeled with flavors. I have my labels at both parts to say what the information is, number of votes being represented by the numbers, and flavors being represented by the flavor abbreviations. I have my title in place. Let's get to graphing. So now if I have my chocolate, I know that I got 8 votes for chocolate. So if I'm counting by 2s, I would go 2, 4, 6, 8. And the top of my bar is going to be at the same level as where the 8 is on this graph. So I'm going to go ahead and start by drawing a line. And I'm not going to draw it all the way over to the 8. I have seen students do this in past classes before. I'm just going to kind of make sure that visually, or you can use a ruler if you want to be more precise, it lines up with the 8. So I'm not going to necessarily draw my whole line there. I'm just going to draw the top of my line there so that then I can go down and you'll see that my bar kind of brackets my first label, which is chocolate. And then I'm going to color it in. And I'm just going to do a quick coloring because I don't want to spend a whole lot of our math time with me coloring. So that's my first bar. My first bar goes up to 8. It shows that chocolate had 8 votes. Okay, mint chip had 5. Now again, my number of votes, my y-axis is counting by 2s. It's counting by even numbers. But if I want to represent an odd number, what would it be? It would be in between the 2 even numbers, right? So in between this point down here at the bottom, which is kind of like 0, and 2, there would be 1. In between 2 and 4 would be 3. In between 4 and 6 would be 5. So just like with demonstrating with half an ice cream, I'm going to demonstrate by having the bar reach halfway between 2 of the numbers. So for mint, oops, grabbed the wrong color. For mint, I had 5 votes. So I'm going to go ahead and have the top of my bar be right in between the 4 and the 6. That's going to be representing 5. So if I draw the top of my bar, bring it down so that it brackets my label, and then color it in. Okay. Next up, we have strawberry. Strawberry has 3 votes. So I'm going to go ahead and once again go in between the 2 and the 4. I know that 3 is going to roughly line up right about there. Bracket in and color. Okay, vanilla, the best flavor, has 2 votes for vanilla. So it's going to correspond directly with the 2 if I kind of eyeball it over. Bring down those lines and color it all the way up to the top. Okay, and lastly, bubblegum, arguably the worst flavor of ice cream, has only 1 vote, which is even surprising. So it's going to be right about here. Bring it down and color it in. And there you have it. So that is how you would make your own pictograph and bar graph, and a little bit about how you would set them up and how to read them. Let's go ahead and get into the lesson at this point. So if you have your instruction books, I'm going to ask you to go ahead and follow along with that. If you do not, I'm going to try to pace you through as much as I can, and hopefully you can get those as soon as possible so that you can work on the pages and then also your practice pages as well. So if you have your instruction books, please go ahead and open them to page, sorry, my pen was running away from me. Page 250 is going to be where we're starting off. So we're starting off with lesson 24, and it says solve problems using scaled graphs. So in this part, we're going to be talking not about making your own graphs. We're going to be getting to that in the next lesson that will also be incorporated during this time. But first, we're going to be starting off with just how to read and solve problems with the graphs. So on page 250, in the yellow box is the question. It says, Ron kept track of the points scored by his teammates during a basketball game. He recorded his data in the picture graph shown below. How many points did each teammate score? So you have a pictograph representation. You have the names of each of the players down the one side. You have your title up at the top. And you have basketballs, which are your pictures representing your data. There's also the key at the bottom, which is telling you what each basketball is worth. So the title says points scored during a game. The people are Alan, Kate, Gary, and May. The key says that each basketball stands for 2 points. So we see that Alan has 1 basketball. If each basketball represents 2 points, then Alan scored 2 points. Kate has 3 basketballs. We can easily find Kate's score by counting by 2s, because remember, each basketball counts for 2 points. So if she has 3, we would count 2, 4, 6. Kate scored 6 points. Gary has 1, 2, 3, 4, 5 basketballs. So if we were to count by 2s, we would say 2, 4, 6, 8, 10. Gary scored 10 points at the basketball game. And May has 4 basketballs. Each basketball is worth 2 points. So May scored 2, 4, 6, 8 points. All right. The questions down below, I'm going to go ahead and go through the questions, and please answer them if you have your instruction book with you as we go along. So A says the sentence at the bottom of the graph tells you that each basketball stands for blank points. So look up to where it says key, and the key is telling you that each basketball stands for how many points? 2 points. So to fill in the question, it says the sentence at the bottom of the graph tells you that each basketball stands for blank points. You would write in 2 points. B, there is 1 basketball next to Alan's name. That means that Alan scored 2 points. There are 3 next to Kate's name. How many points did Kate score? So if we counted by 2s, we would have 2, 4, 6. Kate scored 6 points. How many basketballs are next to Gary's name? If we go up to the pictograph, we see that there are 5 basketballs. Now, notice that it's not asking how many points Gary scored yet. It's asking how many basketballs next to his name. So if we look at the pictograph, we see that there are 5 basketballs next to his name. So how many basketballs are next to Gary's name? 5. How many points did Gary score? D is now asking for how many points. If we count by 2s, 2, 4, 6, 8, 10, Gary scored 10 points, with the 5 basketballs representing the 10 points that he scored. E says, explain how you could find the number of points May scored. I'm going to let you guys go ahead and answer that in your own words. How could we find how many points May scored based on the pictograph, based on what we've already talked about? So I know that we are streaming live. I'm going to ask that you either go ahead and finish up that question quickly or come back to it, because we're going to go ahead and move on. I want to be, we have 2 lessons to get through today, and we're already about halfway through our time. On the next page, on page 251, it says, look at Ron's picture graph on the previous page. The key tells you that each basketball stands for 2 points. You can multiply the number of basketballs by 2 to find the total number of points each student scored. So going back to that last question, question E, if you see that May has 4 basketballs next to her name on the pictograph, you could count by 2s, or you could multiply 4 by 2 to find your answer. On page 251, they have it written out as a table. So they have different categories. One says student, has all the names. The next one says number of basketballs, how many basketballs were next to their name on the pictograph. And then they have a multiplication sign. Points for each basketball would be, or I think it's supposed to be basketball. It says points for each basket, but I'm pretty sure they meant basketball. So the number of points represented by each basketball is 2. And so then you would have equals the total number of points. So Alan had 1 basketball. 1 times 2, you guys know the identity property of multiplication tells us that any number times 1 is going to be itself. So 2 times 1 would be 2. Kate scored 3. 3 times 2 would be like 3 doubles. So 3 and 3 would make it 6. Gary has 5 basketballs. 5 doubled, 5 and 5 would make 10. And May had 4 basketballs, so her score would be double 4. 4 and 4 would be 8. All right. Below that table, it says the same basketball data can be shown as a bar graph. The bars on the bar graph below show how many points each student scored. So if you look at the bar graph, they have laid theirs out as a horizontal model. So bar graphs can go vertically, which means up and down, or they can go horizontally, which means side to side. On my example back here, I decided to lay them out vertically, meaning that my bars go up and down. But you can just as easily go side to side. It's just a matter of preference, and kind of depends on how you lay it out. If I had more data, then my bars would maybe go higher, which depending on the space, since I had more space down here, if I had more data points, it may have made more sense for me to lay it out horizontally so that I could display that data as they did here. Now you'll notice that the first one is Alan. They've laid out, so they've kind of flip-flopped it. Their y-axis now is actually just like our x-axis down here. It's the names of the students. And their x-axis are the numbers. So they have their numbers just like in the pictograph example, counting by 2. So 0, 2, 4, 6, 8, 10, 12. They've also gone a little bit beyond the top score just to give them a little bit of room so that the top of their graph isn't at the very top of their, or their top number isn't at the very top of their graph, or in this case, the very side of their graph. So Alan scored 2 points, so his bar goes over to the number 2. Kate scored 6, her bar goes over to the 6. Gary scored 10, his is all the way over here. May scored 8, hers is right here. Okay. Below the bar graph, it says the numbers along the bottom of the bar graph are called the scale. So anytime we have the numbers on a bar graph, it's called the scale. As I said earlier, on my graph, they were along the y-axis, but on this one, they're going along the x-axis. The reason I'm saying axis is because that's not something that you guys need to know at this point, but it's good with math vocabulary. The earlier you can start using the correct vocabulary for things, the easier it gets down the line when you have more complicated math. So the numbers along the bottom of the bar graph are called the scale. Scale marks off equal sections. So notice we didn't count by, we counted by 2s each time on our graph. We didn't say 2, 3, 6, 9. We didn't skip around. Each increment is going to be the same. So on this one, the scale is counting by 2s. All right. Down at the bottom, it says reflect. Number 1 says, what would it mean if the symbol for Alan was half of a basketball? So just like with our ice cream model here, if we are looking at our key, the key represents, in my example, that each ice cream is worth 2 votes. So half of an ice cream would be half of the 2, half of 2 would be 1. If we look at this example, the basketballs, each basketball represents 2 points rather, and so a half of a basketball in this case is also going to be 1 point. Okay, moving on. We're going to go ahead and skip pages 252 and 253 because they are showing you more pictograph information, and we kind of already went over that. I want to skip on over to page 254. My pen is dead. That's why I have a backup. Over to page 254 so that we can take a look, a little bit more in-depth look at bar graphs. So the yellow box says the Hart School wants to build a new playground. The graph shows the number of dollars each grade has raised to build a playground. Grade 3 and grade 4 together want to raise $300. How much more money must they raise? So now this is a good time to be using your techniques for how to find the information in a word problem and what the problem is asking. So we have a graph to go from. The graph is the amount raised in dollars, you'll see, is on the y-axis going up and down. So we have a vertical model of our bar graph again. So amount in dollars is going up side to side, and our scale, it looks like, is counting by tens. So remember how I said if we get into the hundreds, we might have to have a higher scale. In this case, we're going to be counting by 10. So each mark represents 10. And you'll notice that here's 0, here's 10. 10 is way down here. All of the bars are much higher than 10. So counting by tens was a good choice for this one because we don't have anything that's under or around 10. Most of them are much higher. So if we're having a greater scale, counting by tens, you cover a lot of ground that way, right? 10, 20, 30, 40, 50, all the way. I'm already up to 50, and it took me no kind of time. So if your scale is higher, then that means that you're able to cover more ground. So because we're dealing with numbers that are multiples of 10, we can represent them more accurately by counting by tens on that y-axis. At the bottom, it has grades, so what each grade raised, and it says at the top, the title says money raised for the playground. So second grade, it looks like goes up to the 50 mark. Third grade goes up to the 80 mark. Fourth grade goes up to the 60 mark. Fifth grade goes up to the 90 mark. And sixth grade goes up to, looks like the 40 mark. So that's how to read our graph. But the question is asking something a little bit different. It says grades 3 and 4 together want to raise $300. So that means that the total amount that third grade raises and the total amount that fourth grade raises, they want it to equal $300. The question is saying, how much more money must they raise? What does that tell us right there? There's a key word in there, and that key word is more. So what does that more tell us? Does it tell us that they're at their goal yet? No, it tells us that they are still working towards reaching that goal. So how much more money must they raise? We can guess pretty accurately that they are not at that goal yet, that they need more money to get to that goal. So let's go ahead and look at our graph again. It says third grade, we see, has already raised $80. And fourth grade has raised $60. So this is what we know so far from our graph. Now, to solve this problem, we are going to need to figure out how much more money they need to raise. So we would be adding the numbers that we have already together. So we would see 80 and 60. I know that 8 is really like 6 and 2. And the reason I'm breaking that up is because I like doubles facts. I know my doubles facts really well. So I know that 6 tens and another 6 tens would be 12 tens. And 12 tens is like 120. But that would be if this was 60 and another 60. It's not 60, it's 80. So like I said before, I know that 8 is like 6 and 2. So I took 6 tens from my 8 tens, and now I'm going to add on another 2 tens to make it the 80. So if it were 60 plus 60, I would get 120. Since it's 80, I'm going to add on 20 more to the 120 that I would get if this was 60. 20 plus 20, I know, makes 40. So together, they have $140 that they have earned so far. Now, their goal is to get $300 together. And what we're trying to figure out is how much more money they would need to get to reach that 130. So we can think of it, we know that together they have $140 already. So we can think of it as $140 plus what number would get them the $300 together. Another way to think of this is we're starting with our 300. We could take away the 140 to figure out what the mystery number would be. So that's precisely what I'm going to do. So I'm going to go ahead and take my 300, take away 140, figure out what that would be. Now, we can go through this and regroup, because if I go through it, 0 take away 0, I know is going to be 0. But then I have 0 up here and I need to take away 4. If I have 0, do I have 4 that I can take away? Nope. So I could think of it in terms of regrouping, but I'm going to go ahead and take a shortcut. I know that 150 plus 150 equals 300. Because if I take away the zeros, I also happen to know that 15 plus 15 equals 30. So it's really the same thing. I'm just adding a 0 in my place value. So 150 is pretty close to 140. So I'm going to say if this is 10 less than 50, in order for it to still come out to 300, this would need to be 10 more because I took 10 away from here. It's no longer 150, it's 140. So I'm going to take 10 from my 140 and add it to the 150 I have here. 150 plus 10 more would make it 160. So my 140 is here, my 300 is here, my mystery number is 160. They need $160 more to get to their goal. Now, you can work through the problems on page 255. I would strongly encourage you to do that. But for the sake of time, we are going to go ahead and skip those and move on. So if you are following along in your practice book with me, I would like you to please go ahead and turn to the next lesson, which starts on page 260, but we're actually going to skip that page too and go right on to page 262. Please turn to page 262. All right, so earlier we talked about how lesson 24 was how to interpret data on bar graphs and pictographs. Now we're going to be talking about how to draw your own. And the most important pieces that I can emphasize on these is that when you're dealing with a pictograph, you need to have a key. When you're dealing with a bar graph, decide on your scale. You need to have both axes labeled, whether you decide to go on with a vertical model or a horizontal model, both axes need to be labeled, and both your pictograph and your bar graph should have titles as well. Okay, so drawing a scale pictograph, we're starting on page 262. In the yellow box, it says, Robert records the different bugs he sees. He wants to draw a picture graph using the data in the table. How can Robert make a pictograph? So it has a table already with some of the information about how the types of bugs Robert saw and the number of each bug. So we see types of bugs are ants, bees, moths, spiders, and number of bugs. He saw 16 ants, 4 bees, 6 moths, and 12 spiders. Below that it says picture it. You can use models to show the data. They say you want to use a scale of 2. So they're giving you the scale. And they're saying that each bug picture, use a bug picture for each bug, then draw circles around groups of 2. So I'm going to make my bug pictures even more simplified than their bug pictures. So they're showing you that for every 2 pictures, or for every 2 bug pictures, you would put a circle around it. That would be a representation of how many would be in your scale. Model it says you can also use multiplication to help you show the data. They're actually flipping that around to use the inverse, which is division. So it says still use a scale of 2. Now each bug stands for 2 bugs. So if you had 16 ants, you would think about what number times 2, which is our scale, would equal 16. They're also telling you that you can think of it as 16 divided by 2 equals what number. And you guys know that these are fact family facts, and so we can do it either way. So we can think of it as a multiplication problem. What number times 2 equals 16? Or the inverse of that, 16 divided by 2 would equal some number. For the sake of time, I'm going to go ahead and skip on over to the other side where it says connect it. Now you will solve the problem from the previous page by drawing the picture graph. So what is a good title for Robert's picture graph? Write it on the picture graph below. So there's a line, just like I had a line above my picture graph for your title. I would go with the same title that is on the data chart on the other side. Bugs Robert saw. That sums up the information that you are portraying. It's short, it's to the point. So go ahead and write in on that top line, bugs Robert saw. They've already started drawing in your picture graph for you. They have ants and bees already written in. What would be the next category? So they have a blank category under bee. And if we look over to the table on page 262, we'll see that after bees, there are moths, and then the last category would be spiders. So go ahead and write in moth and then spider in the 2 blank boxes under the types of bugs. Now they filled in ants and bees. Each bug, remember we decided that our scale, each bug is going to count for 2 bugs. So each bug picture is going to count for 2 bugs because our scale is 2. So down at the bottom where it says key, write in each bug stands for 2 bugs. For the sake of time, I'm going to go ahead and say that you can fill in the rest of your picture graph on your own, filling in how many bugs for the remaining categories of moth and spider. We are going to go ahead and turn the page to page 264. And now we're going to be talking about creating your own bar graph. So the problem says Nan keeps track of how many minutes she practices the guitar each day. She wants to draw a bar graph using the data shown at the right. How can Nan make a bar graph? So you can see on the page that there is it looks like a little torn out piece of notebook page. Time I practice guitar, Monday, 5 minutes, Tuesday, 30 minutes, Wednesday, 15 minutes, Thursday, 25 minutes, and Friday, 20 minutes. Below the yellow box, it says picture it. You can use number lines to help you choose a scale. So in this case, the number line has a scale of 5. And if you were to draw a dot for each of the data points from the table that is along that scale, you would see that there's 5, there's 15, 20, 25, and 30. So a scale of 5, so counting by 5, would be a great choice for this one because all of those numbers are multiples of 5. 5, 30, 15, 25, and 20. All of those could be divided by 5. 5 would be a factor for each. So that would be a good scale. Below that, it has an example of a scale of 10. You'll notice that the dots do not fall evenly on the coordinates. So if we're counting by 10s, we have several dots that are in between other areas. So 5 would be in between 0 and 10, because remember, if we're counting by 10s, halfway would be 5. 15 would be halfway between 10 and 20. We have 20 and 30, and then we have 25 would be halfway between 25 and 35. Since some points fall between the scales, this would still be a scale that would work okay, but I would recommend in this case counting by 5s because you would hit all of those data points. Below that, it says model it. You can also use multiplication to help you make a bar graph. For me, it's easier to think of it in terms of what would I get to by skip counting. But as I mentioned, you can also think of it as multiples as well. On the next page, 265, it says connect it. Now you will solve the problem from the previous page by drawing a bar graph. Number 5 says, how do you use the scale to help you draw the bars on the graph? So if you look at the graph model in yours, they have it laid out following a horizontal model, in that your numbers are along the x-axis and the days of the week are along the y-axis. So we would have Monday, Tuesday, Wednesday, Thursday, and Friday. So these are going to be where our bars are originating from and going out. And then your scale along the x-axis is going to be counting by 5. So once again, the corner always starts with 0. So our first one would be 5, then 10, 15, 20, 25, 30 is our highest time. So I'm going to go one more from that so that the top of our graph isn't at the very end, and do 35. So I now have my scale counting by 5s along the bottom. And then and on theirs, they have 30 is the last one. I like to give myself a little cushion, but they have done it differently. And then days of the week on the side. Now remember, with a bar graph, we're also going to give it a title. So she put on the top of her list, time I practice guitar. We're going to follow that model and say time but instead of I, because it's not our time, we're going to say time Nan practices guitar. And because my whiteboard is kind of small and my marker write's kind of big, I'm just going to write time Nan practices. But I want you guys to write in time Nan practices guitar. And then we also need to label both of our axes. So we need to label the y-axis as well as the x-axis. So the y-axis, we have days, right? Monday, Tuesday, Wednesday, Thursday, Friday. So I would write day as my label for my y-axis. And then down below, our x-axis is going to be how many minutes she practices, right? So we're just going to go ahead and write number of minutes. And if you guys want to abbreviate number to that number sign, I am totally fine with that. So number of minutes. So now we're going to go ahead and draw our bars out. So on Monday, she practiced for 5 minutes. So we're going to have the end of our bar correspond with the line of the 5 and then shade it in. I think it's already in your books for Monday and Tuesday. Tuesday, she practiced for 30. So our bar would go all the way out to the 30 and come back and shade it all in. On your graph in your book, it's going to go all the way to the end of the graph. I think that's not as visually pleasing as giving yourself a little space at the end, but that's just my 2 cents. Wednesday, Thursday, and Friday have ones for you to fill in. So Wednesday, she practiced for 15 minutes. So I'm going to find the 15 bar. I'm going to draw my little line, bring my bars down. I think that's an easier way than doing it like I did here where it gets kind of wonky. And shade it in. Thursday, she practiced for 25 minutes. I'm going to go over to 25. Nope, that's getting into my Wednesday line. Thursday, shade it in. And Friday, she practiced for 20 minutes. I'm going to go to the 20 minutes. And here's Friday's bar. So that's how you would draw both a pictograph and a bar graph. That's also how you would figure out some of the information from them. So once again, just to kind of summarize, we covered lessons 24 and 25 in your instruction books. So we started on page 250 and we're ending on page 265. I would strongly encourage you to go back and do some of the questions that we rushed through. Because the more you do it, it's going to be more practice. And the way the book is laid out, it does it step by step. I'm also going to assign you practice pages in your practice books. They may be loose pages because I did tear out the next few lessons in anticipation that we would be doing this in class, not online. So you may have to look through some loose pages in your packets instead of in your booklets. But you're going to be looking for the pages that I'm going to assign to you. You might want to grab a piece of paper and a pencil to write it down. You are going to, but remember, you can also always go back and rewatch this video too if you forget. I will also be posting your assignment on Google Classroom for your practice pages. Practice pages, I would do both sides 265 and 266, 267 and 268. Those are going to be how to read and answer questions about pictographs and bar graphs. And then I would also like you to complete pages 275 and 276. So those would be double-sided pages, and 277 and 278. Those are how to draw your own pictograph and bar graph respectively as well. The due dates for these, typically, if we were in class, those would be assignments that I would have you do in a week. The timeline is a bit more flexible right now. So just to let you guys know, we have 6 lessons. We have 6 lessons left in our math book, and we have 10 weeks of school left. So, so we have more weeks than there are lessons. My plan is I'm going to be doing a lesson per week until we run out. And then the last few weeks I will use for catch up and anything that you guys have questions on that you may still want answers to. So I'm going to still be posting a lesson a week, but remember that you can kind of go at your own pace. So that's the nice thing about this distance learning thing, is that the due dates are a lot more flexible. So if you are finding that those practice pages, it's taking you a little bit longer to complete those, I'm still going to be doing another lesson online next Tuesday for you guys. That will be a new lesson, but you can watch that at any time. It doesn't have to be just during the live streaming time. And I will be available during office hours, Tuesday, Wednesday, Thursday, between 10 o'clock and 11 o'clock on Google Hangouts. With that said, I hope you guys enjoyed the lesson, and I'll talk to you soon. Okay, bye.